I am Sadish Kumar from Manipal Academy of Higher Education. This is the second episode of atmospheric optics. Here we are discussing about the common optical phenomena which are being observed in the atmosphere in different situations and different environments, of which we have discussed about the formation of rainbow. Now there is another significant effect which is observed in the sky during the sunset, which is known as a green flash. Actually, green flash is a rare phenomenon which can be observed in a clear sky condition, but in tropical regions it is very impossible to get clear sky conditions during sunrise and sunset, but in the polar region it is commonly observed, and of which one of the important effect is the green flash. After the sunset, one can really see a green color at the top of the sun. This is mainly due to the refraction as well as the mirage, which I have already explained in the last episode. The combination of both the mirage as well as refraction causes the green flash, which is observed after the sunset as well as before the sunrise in the morning in the polar region, which is a clear cut indication of a clear sky. That is the significance of this one. So, actually this is a situation. We have refraction in the atmosphere. This is the horizon. You can see that whenever we look from here, we can see different colors, of which after the sunset we can see different colors, of which this blue is prone to be scattered very large, so that green is visible. Now, another important one is the halo, that is the bright ring around the sun, which is commonly observed in everywhere. Actually, the phenomenon is, we know that in the atmosphere we have clouds. When clouds are ascending at a slow pace, it gradually cools up. As the clouds containing water vapor and ice crystals, whenever it ascends slowly at a constant speed, what happens is the ice crystals gradually develop, and if these crystals are formed in such a way that if the angle of a crystal or any angle of the crystal is 22 degrees, then light will be, when sunlight comes, sunlight will be refracted in a circular region, circular form, and this circle is, we can see this circle, which is the result of refraction through the ice crystals, which is in a color of yellow, and we have other yellow and red and or primary colors. So, this is the this is the ice crystal, you have incoming sunlight. So, when the angle of deviation is 22 degrees, that means the angle of the crystal is 22 degrees, the angle of deviation is also 22 degrees during refraction. This effect will be pronounced in the sky. So, this indicates the fact that the atmosphere is stable, because the formation of ice crystals in a slow manner means atmosphere is stable, it is free from convection. So, actually this halo tells us that the atmosphere is stable and it is quite calm. There is no possibility of a rain or a thunderstorm in the coming days or coming week. So, we can observe a clear sky during the whole week. So, this is 22 degree halos, right. So, this is the basic science behind it. Now, here what happens is, this is the actual situation. We have ice crystals and sunlight is coming, and if we look at from here, we can see that a round structure or a round halo, but here, since the ice crystals strength or the abundance of ice crystals are more on the sides, then that part will be more intense. Here this part will be more intense, and which depends on the number of crystals. So, here you can see that this is the number of ice crystals. If the number of ice crystals are more, then what happens is we can see the we can distinguish, or we can see the contrast of the halo which are produced. Now here, as we have seen that the number of ice crystals are varying across the cloud, so that there is a possibility of strong intense light on the two diametrically opposite side of the halo. They are known as sun dogs. So, sun dogs are actually formed by refraction of light in the halo, but on the opposite sides the intense light beam. So, this is known as sun dogs. Sun dogs means actually sun, you can see sun is at the center, you can see that sun is at the center, and the two bright spots are on the either sides of the center of the sun, which are known as watchdogs. Therefore, they are known as sun dogs. Now, another important factor is we can see that sometimes you can see a pillar like structure while during the setting sun. Actually, what is this is ice crystals are slowly descending down. When ice crystals have masses, when masses accumulates or its weight increases, so that ice crystals slowly started moving downwards. And these ice crystals, when they are moving downwards, what happens is when sunlight passes through it, slowly we can see that this is just like a pillar structure. So, the vertical movement of ice crystals, that forms a pillar like structure, which is known as sun pillars. So, this is observed during the setting and rising of sun and caused by the reflection of horizontal ice crystals. Now, so sun pillars actually they are from ice crystals. So, ice crystals means ice crystals formed in the clouds. Therefore, these clouds are at a larger height, so that it will not produce rain. Therefore, the condition of the atmosphere is very stable and a fair weather we can observe during this situation. Now, so these are the things in the main physics. So, this is the therefore, what happens is this can be observed at an angle of 22 degrees. The vision is at 22 degrees, we can see this sun dog and sun pillar. Another is corona. Corona means actually we can see a colorful structure around the sun, which is known as a corona. Actually, it is the bending of light around an object. Actually, this is known as diffraction. Therefore, diffraction forms corona, which appears in different colors. Now, one of the main important optical effects which happens in the atmosphere is scattering. When light is allowed to pass through a medium which contains dust particles or molecules, then light interacts with these molecules and dust particles, so that it deviates from its original path. It is otherwise classified as scattering. So, we have forward scattering, we have backward scattering, depending on the nature and geometry of and environment of the particles. So, this is an interaction of electromagnetic radiation with the material. So, we have a different scattering. One is Mie scattering and another is Rayleigh scattering. Rayleigh scattering means molecular scattering is otherwise known as Rayleigh scattering. When sunlight passes through the atmosphere, it interacts with molecules present in the atmosphere, so that light will be split into different components or wavelengths. So, we have Rayleigh scattering. And if the particle is little bit large, for example, dust particles, the scattering property will be different. It is otherwise known as Mie scattering. Now, here we have scattering properties. We have forward scattering, means more light will be scattered in the forward direction rather than the backward and side directions, depending on the size of the particle. Now, here we have, this is Rayleigh scattering. Rayleigh scattering means the intensity of scattered light is 1 by lambda raised to 4, where lambda is the wavelength. Therefore, it is inversely proportional to the fourth power of the wavelength, means more light will be scattered for lower wavelength. That is why sky appears blue because the blue color is the wavelength is less. As a result, it has a tendency to scatter more. And the setting sun is red, because light has to travel a larger distance to reach our eye. As a result, what happens is the all colors will be getting scattered while reaching us. So, only red color will remain. Therefore, setting sun and rising sun are considered to be in red in color. So, this is Rayleigh scattering. So, actually this is the equation for that. It depends on the angle through which one is observing. So, this is the blue sky. You can see that blue radiation, red radiation. Therefore, this is a simple mathematical step which can show that blue scattered is 4 times more than the red radiation. Now, this is the color of the red during the setting of sun, and this is the explanation for that. Now, here this is another simple example, that up from here to here the sky is more blue and here it is less. Here it is less, which is mainly due to the presence of dust. If the dust is more, the scattering intensity will be less. Here you can see, because scattered light will be in different directions, therefore, the intensity is less. So, here the dust, the abundance of dust will make this color, while here the sky is clear, therefore, the sky is more blue. So, this is the observational feature. One can really test whether there is the possibility of finding any dust particles at a certain height. Then it is possible by using this result. And another important is crepuscular rays. Crepuscular rays means when sunlight is allowed to fall or pass through a bush of trees or canopy, then we can see that light is traveling in the form of a ray, a bundle of rays. So, this, for example, you can see this one. So, these are otherwise known as crepuscular rays, which is considered to be another optical property, but it often creates optical illusion. That is the main point. And here this is the fog. If morning fog is there, definitely we can see that the crepuscular rays which are passing through it due to reflection and refraction. Here we can see that how one can visualize this. For example, if the atmosphere is contaminated with dust, then we can see that the rays which are coming from a farther distance will be narrow, while the rays which are coming from a shorter distance will be found to be thick. So, there is a distinction between these two. So, in order to understand this is a laboratory classification. These are all laser beams passing through in a smoke containing room, so that the path is very clear, distinct paths. But we can see that some of the laser beams have a thick cross section and other is thin. This is thin while this is thick. Actually, their size are equal. This produces an optical illusion. Therefore, crepuscular rays often creates an optical illusion than the actual situation. So, this is Rayleigh scattering. This is a comparison between Rayleigh scattering and Mie scattering. Rayleigh scattering is molecular scattering and Mie scattering is particular scattering. Therefore, you can see that Rayleigh scattering, the scattering is in all directions, but Mie scattering is in the forward direction. Therefore, there is a substantial difference. The consequence is that if the dust particles are present in the atmosphere and sun is shining on the top, then when light is passing through the particles, what happens is the forward scattering is more. That is why more sunlight will be, more energy will be reaching at a certain point. So, this is always happening in deserts. That is why desert atmosphere is more hot than the other locations. Now, this is the equation. Now, here how to measure this, how to measure the abundance of dust particles. So, this is a device which is known as a sun photometer, which employs the scattering of light. So, the scattered light in different wavelengths can be collected by using this device, from which we can calculate the size of the dust particles present in the atmosphere. So, this is a simple graph. Each and every wavelength shows the characteristics of different sizes, the particles with different sizes. Now, this is a simple example that actually, if you look at in certain locations, for example, if a place where a volcano eruption has happened, then instead of a clear blue sky, up to certain region one can really see a red region also, or red sky also. This is due to the fact that the dust contamination at this region. So, in our place also, while looking at the setting sun, sometimes we can see the atmosphere is instead of blue, we can see it is red, which means that the presence of dust particles. So, when dust particles is there, there is a possibility of observing a red color. Now, this is this is aurora, which is something different, but which is often observed in the poles due to the ionization of molecules or gases. Now, this is the actual crepuscular rays, but crepuscular rays means it always creates some illusion. Actually, it moves along the empty spaces. Some part of the light will be blocked and other part will be transmitted. So, we will see sometimes just like a halo effect. So, this is another part in the atmosphere that depends on the position. And in the morning also we can see this one. This is very common. So, what is the significance of this? This is mainly happened due to the presence of fine dust particles in the atmosphere. Therefore, when fine dust particles are there, there is a possibility of growth of cloud. So, if it is there in the evening, then there is a possibility of rain in the late night, because particles are there which are quite favorable for the growth of clouds in the night. Therefore, there is a possibility of midnight rain. That is the significance of this crepuscular rays. Now, this is 3 different methods by which one is observing our earth from the top, means of satellite. Here, as I told you that earth is getting heated up due to the presence of the sun. So, that infrared radiation or long wavelength radiation is going out, and if you have a device which can collect only the infrared, then one can image the infrared radiation. And here it is the visible radiation. So, that it is visible part only, and this part represents the water vapor. So, water vapor means the idea of monitoring water vapor is to monitor the clouds. So, this can predict the weather conditions, this water vapor channel, right. So, in this one, here you can see that different locations are marked with the different colors. For example, generally oceans are observed as blue due to the scattering process, and mountains are denoted by the brown color, and clouds are always in white color. So, there are distinct colors which can earmark the presence of different objects. Here also this is a infrared, means this is hot places. Hot place means that may be a desert, and this is a white place, means it can be a snow. Therefore, there are different methods by which one can really look the object, its temperature as well as its environment. For example, if you take water vapor, here water vapor means the movement of water vapor. Movement of water vapor is nothing but cloud. So, one can, if you have a satellite image, you can really get the presence of oceans and ocean conditions, and the presence of snow conditions or snowfall, and the third one is the movement of clouds. So, these are the methods by which, the optical methods by which one can really explore the possibilities of the investigating our atmosphere as well as the land. So, I think this is the method by which one can really employ remote sensing. That is another important topic which will be done in the later sessions. So, I think we have already discussed some important parameters, important effects. One is refraction, and another is diffraction, and another is reflection, of which refraction produces this halo, and refraction as well as the total internal reflection or the mirage effect produces the green flash, which is one of the rarest phenomenon, and we have this sun dogs due to the refraction process, and the sun pillar, which is an extended version of sun dogs when the ice crystals are falling down. Therefore, these are the common phenomena which we have observed in the atmosphere at every location, but most prominently or it is most pronounced in the polar region than in the tropical region because of the heavy convection. So, one has to explore only with the help of science to understand a deep level for its causes and its effect in a scientific term, that we will discuss later. Thank you.